Boy, a lot of familiar faces that I saw before, sitting in the same seats. That's what's amazing. I see Norm over there. That's where you were before, Norm. Do you remember that? These two have been right in the same seats. You didn't move, right? Good for you. Okay. Unbeknownst to me, when Marlena said, would you develop 8 different programs for us? I teach 4 of them. Tina teaches the other 4. Sure, not a problem. Wow. Don't ever do it. Okay, the last one on here, I think it's a good one to wrap up things, is on the sediment controls. And again, if you've been following me around, you heard me in the last session harping on erosion control as much as you can. And Tina taught an erosion control class, if I'm not mistaken. Well, I know she did because I developed the PowerPoint for it. But sediment controls, I want you to think about what are some of the limitations. Everybody hear me in the back room okay? Okay. So with that in mind, when we talk about what's sediment, always keep this. People saw this before. What's sedimentation? People seen this before. I'm just going to go real quickly on what's going to be erosion. Seen all that before. But how do we remove sediment from runoff waters? And the thing that's important here is don't always think sediment is the material that's deposited in front of an inlet, if you're lucky, or goes into the inlet. But the deposit of solid particles is not the sediment that I'm more interested in. I'm interested in the sediment that's in suspension. When the water during the flood flow events is nice and brown, that's all because of sediment, or predominantly because of sediment. Okay, here's one way of doing it, and this is whenever you put in any type of check structures, you're reducing flow velocity. That's a sediment control. Filtration, that's another way of getting rid of water to leave. That's all there are. You're looking at all of them right there. And you look at this and say, wait a minute, reduce flow velocity. Well, you change the gradient, you reduce flow velocity. Increase surface roughness, you reduce flow velocity. You contain runoff water, you're doing sediment control. That's your fiber rolls, that's your silt fence, and the only one that really works, sed ponds. That's the only one that really you're going to get max bang for the bucks. So, commonly used techniques are silt fence barriers. And how many of you can say your projects look like that every time it rains? And somebody says, oh my gosh, look at all that sediment there. Yeah, well that's bad, it's all filled up. That daggum silt fence is causing a problem. It's capturing sediment. Guess what? That's what you like. And notice the sidewalk. And if you look at the series of these, this one overflows into that one. If that filled up, that would overflow in the bottom one. Good planning. Good planning. How many details do you see of that one in that shape? Probably none. That's the part there as designers, you got the technical and academic skills to do these things. Doesn't mean you can't do anything up in here. You're going to have to, but that's what you like to see. Fiber rolls. You use a lot of fiber rolls around here. And I said last time I was in, I think it was in this room, I've been running from room to room. If you can lift that fiber roll up, it's not going to be effective with one hand, that is. You're going to have to either weight it down or soak it or something so that the internal stuff can become very saturated so it hugs the ground. So keep all these things in mind as we go through. California uses sandbags. We don't use sandbags in Colorado because there's something called snow plows that just love to destroy those real fast with the blade. And hopefully none of you ever request to have straw bales on your project. They only work when it doesn't rain. So keep that in mind. Okay, with that in mind, Don't forget some of the geosynthetic ones that are out there. These are good ones. This happens to be, whatever it is, that's what it is, Jerald. But keep in mind, it's only that tall. And when it's only that tall, it cannot contain much water. You want something like that to have effective sediment control. And they're hard to implement and hard to put in there at the right times. Guidelines. Does water go underneath? I'm sure nobody's ever seen anything like this in Hawaii, have you? Can it go around? This is milk cartons filled with rock. If that was all the way over to here, it worked great. It flooded the intersection just like I like to see it. Most contractors, and I don't blame you, they don't want to see it. DOT, you don't want to see it. You have an alternative. Think about the alternatives. I love that one. Can anybody tell me what the heck this is doing? Somebody said, oh, we're protecting the fire hydrant. Yeah, okay. But why would you have a gap in there, for crying out loud? So, you know, we see the most strange things that goes on there. Denver International Airport. That's going up a hill. This is exactly what the contractor saw on the drawings he was handed. There's your key thing. What you put on there on your drawings are what the contractor's going to put in, because he bids on these things. And if you have stuff that goes up the hill, along the contours, on top of the hill, that's what he's going to put in. Plus probably a lot of other ones too. But, you know, these are things that we as designers should never have to do it. Okay, as we go through on this one you say, God, it's working, right? I would reject it. I would write that person up as an NOV until you correct it. There's a violation. Why? Because if you look at this one, look at the water going around the edges. It's going to be just a matter of time before that's going to erode away, that's going to erode away. I guess you could technically say, well, hey, we got to clean that out. Notice the shape. There's a low point. How many of us, and I'm included, have seen barriers that are straight across in a check structure or wherever when the water needs to go over to the middle of it? Bad installation sometimes. I throw this as a giggle factor. It takes less than 6 inches of water to float a 50-pound bale, by the way. Fortunately, we're out of this. Okay, silt fences themselves. You know, if this is why I say, designers, go out and do an inspection yourself at least once a month. You will learn so much of what works and doesn't work for your next set of plans. I was amazed how stupid I was on sediment erosion control until I went out with the contractor. And you don't want that. This is what you want. You don't want that. And you obviously don't want that. Now, does that mean it was a bad design? No. It means probably, maybe I should say, that the plan that maybe didn't show some type of channel in here. I don't know. It's hard to say. But the thing about it is, it's failing. The first thing you as a designer should say, okay, we better find out why it failed. Well, maybe it was a 10-inch storm event. I don't know what it is, but find out. It might have been the fact that it was just too much wrong BMP at that location. So it looks like there's a lot of upgradient type area there. So you got to look at them. And this is a biggie. Never, 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 never to the 10th power put silt fences in a drainage channel. Bad, 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 bad. Why? Because they will always fail. They will always fail. So, if you have a plan that shows this in here, replace it with something else. I'm not going to tell you what it is, but replace it with something else. Failure will be the norm when you have things in drainage channels. I've seen these all over the nation. So now, instead of a silt fence, we're seeing a fiber roll down the middle of that. Is it working? Designers, have you gone out and looked at it? Is it working? That's the question I'm asking you. If it fails, is the failure because of the contractor or because the designer put something in there they should not have put in? That's your question to answer. Yet you can do it right. Look at that. How many of your silt fences can hold back that much water in a drainage channel? The technique that was used in this thing is called slicing. The fabric is sliced into the ground about 8 inches and held up with metal posts. Just a different approach. There's so many things in there to talk about. If you're talking about a check structure, this is a check structure, can do erosion control and sediment control. What you're seeing right there is the fact that it's doing sediment control here, but it's not doing anything for erosion control up here and not very much erosion control down here, is it? So how do we put those in? What's the most important part that we can do in this thing is, well, how frequently do you put them in there? I saw a plan the other day, put check structures every 50 feet apart. For what slope? Flat land? 15% slope? Did you look at that? No, that's what was in the manual. It says put them every 15 feet apart. We've done it for 25 years that way. Wrong answer. Think about them. Analyze them. See what works. See what doesn't work. Because you'll get some deposition here, but you're going to get a lot of erosion over there, and that you got to be very, very careful about how you handle them. Always a smiley face should be on every single check structure in a drainage channel. You got to have a smiley face. If you don't have a smiley face, it will not work. Be prepared for extensive maintenance, though. As long as you do that, you're in good shape. Here's a case where sediment control, nothing control. So you just got to look at it. This is what I would classify as show and tell. It's not going to do anything. Look at the height of that, 6 inches. That's 12 to 14 inches high. Big, big difference. These things, when I see them in a drainage channel like that, you're trying to fool the inspector. And Claudia doesn't get fooled very frequently, from what I understand. So, that, bad news, everything went around. You don't like that. That's okay if it's installed right. Here's a series of them that you try to look for. This would have been better if that one would have been a little bit closer so the water could cascade off from the top one onto the bottom pond. That is erosion control. So you got the sediment control, you got the erosion control, depending on what you're using it for. That's erosion control, the sediment control here, but don't know what's else up in here, but it looks like to me, having an erosion control blanket in a drainage channel, turf reinforcement mat we call it, hey, that's the best thing you should use, and this is probably a waste of your money. Did you design it rightly? Did you do shear stress? Did you do velocities? Did you use something called, remember Manning's equation? All these nasty things that we tend to forget now that we're out of school. You've got to keep them, incorporate them. Inlet inserts. I like inlet inserts. I think they're one of your better things in Hawaii, because this way you don't have to try to remove them when the streets flood. But if you look at that, of the two, think about the volume. Look at the difference in volume. Talk to distributors over here. Find out if they carry them. I don't remember the names on these. I call it a witch's hat. There's a different name on it. I know it is. Do they work? I'll let you decide that. of all the BMPs for sediment control, this is the only one that you have a fighting chance to really knock down the soil particles in suspension. But you got to have right away to do it, don't you? And that's a huge problem. So there's another one of our problems on there. Do we have enough area to do the ponds if we're going to do it? A lot of you may not want to have a pond that big, but how about a small one like that? The water comes in there, it's going to go right out this way. Turned out to be extremely effective. I don't know what the numbers were, but it sure knocked things down. This was a temporary one. Contractor came up with that idea. He says, look, all I got to do is line this thing, and then we can have water pouring there. It'll take care of it. And he says, we'll pump the water out. And the only thing I did on it, pump it from the top of the pond. Why would I pump it from the top and not the bottom of the pond? Where's the sediment going to be at the most? Top or down here? These are logical things that comes on it. When I see a pond, though, this is what I usually see. I see a pond that looks like that, and I say to myself, okay, there's sediment, nice clean water. Not. When it rained, that short-circuited right into there, and that's what we saw in Florida. Was that expensive for the contractor? Wow. Was that expensive for the permittee? You bet, which was Florida Highway Department, by the way. So there's so many things that got to go in there. Now, here we have a beaker of water, and you have no idea how much sediment I put in there or soil I put in there. But what would be your guess of how much of the total volume here is sediment? Anybody want to take a guess at 50%? Good. Anybody want to take a guess at 30%? Good. Anybody want to take it at 10%? Yeah, that's the one. Anybody want to say, I don't give a darn? Okay. After about 96 hours. This is what I'm saying. The predominant amount of volume when you have runoff, maybe 5, perhaps 10% might be sediment. The majority is water. That's a heck of a problem to try to take care of for sediment control, isn't it? You've got to get rid of water. That's the thing that comes out of it. Runoff, volume of sediment runoff is very, very small. Bottom average slope of the watershed, the estimated percent of sediment in runoff. It's just a math calculation. If we go about 5%, look how little it is. That's relatively flat. Let's go to what's classified as steep by state of Hawaii, 15%. Look at that. Depends on your soil, doesn't it? Depends on the angle of your slope, of your contributing watershed. Depends on whether or not you got this type of slope. And this is probably where most of you are, is right in there, I'm suspecting. I don't know for sure. But steep slopes, they're killers. They're killers. That means erosion control, erosion control, erosion control during the construction phase, not at the end of the construction phase. How are we doing? Okay. This one I brought up in my other class before, the impact in there. I ask again, do we put these things in front of all inlets? Just remember, they divert water. If they divert water, they cause downstream flooding. That's the only message that comes out of it. I don't give a darn about what the picture looks like. By the way, those are rock, what we call rock burritos, that the water going down for that storm event moved out of the curb line. I've seen them here. This is over in Kauai, where I saw this, and it's on a grade going down, wrapped around right into here. They've tried their darnest to try to take care of it. Water comes down that channel, which I never saw, but that's what it's supposed to do, and comes in there. Think about the water that's going to come in there off that channel, going through that little curb cut into here. What's it going to do to that barrier? It's just going to push it out in the road. Why do we put stuff like this on our drawings? That isn't going to work. Somebody says, well, it's all going to collect in here. But don't forget, water has this force with a velocity. It's just going to really take that little burrito and just kick it off. And especially if that burrito is dry, that you can lift up with one hand, which we could at that site, by the way. It ain't going to work. Get the better specs is what I'm saying. If it comes in there, it's going to divert the water down there. It's going to divert all the water down to a low point. That will eventually flood. I wish I could have been around and seen it because I understand it rains once in a while in Kauai, every once in a while. But that's the things that you as designers got to be careful of. Be aware of all these limitations on there. Because you put a barrier in front of any inlet on a grade, your first thing you're doing is setting up flooding downstream. And nobody likes flooding. Let's take a large scale perimeter control on here. How about a little bit of an intersection? And where are going to have sediments in here? Now this is one part of we have another class that designers, and again, I'm giving you about a 30-minute to 6-hour class. But over into here, these are detention ponds. If you have a detention pond, what can you do with that detention pond to help you out on a construction site? Make it into a sed pond at the beginning, not at the end. It's good planning is what it is. I mean, all of us like to see a highway project like this. It's beautiful. This is in Alabama. This is what we start off with. Well, look at that, before grading. Now I'm going to ask you to think out of the box because I'm going to give you something totally different that's in your spec sheets. Why? Because I'm standing up here and you're sitting down there is a good reason, I think. But sometimes you need to see some other things in here. That's going to be the footprint of the intersection. We're going to take a look on the west side of that intersection. So we're going to concentrate onto here. And notice the first thing you see, basin divides, discharge points. That's the hydrology you have to do on every one of your plans. You should always do hydrology. That's what's going to be during construction. So here we are. Before grading, there's my plan 1. During construction and grading, there's my plan 2. And after grading and construction. I like to see 3 plans, not a single plan that has everything that you can possibly find in your tool chest to put on that one drawing. And make the drawings not that little, make them big. Because if you make them big, then you can make the corrections and you can work with them. Well, this particular one, just to go through, for the people who've never been on a highway project before, I kind of think that's a little bit of a difference in here. There's my center line. There's my center line from plan and profiles. I like plan and profiles. I like to see what the contours are. I like to know what your area is that you're working on. Approximate layout. There's my difference in elevations. There's the low point. There's my high point. And a big valley for low point. We've learned a lot here. That's going to be a booger. There's a box culvert that went in there, by the way. Okay. Now, if we take a look at all this stuff here, we say, well, there's got to be a cut section in here that's only showing along there. What's happening over here? What's happening over there? Did you look at that? Did you do the contours for the whole site? Did you analyze it for where water runs? That's what you need to do. And you go and look at all these things of what's happening on here, where the cut and fills are going to be located, and what sediment controls would you use during grubbing? Thank you. I'm getting closer. Well, this is one where you're in a situation that you could, I guess, if you really wanted to, and this is the approximate cut area, this is the approximate fill area. You could, if you really wanted to, put silt fence all over the place because it's the magic panacea of the world and it always works for everything, right? Yeah. How are you going to do it during an active construction site? It's going to be tough, isn't it? So this is the scheduling that you got in here. To work with the contractor, to work with the regulatory people, everybody. When do we put this stuff in here? How often do I, as a designer, go out to see how things are going with the project? I, as a designer, should go out as soon and as often as I can, because that's my project that you're doing BMPs in. Well, design, I don't know about you, but sometimes silt fence can be pretty expensive when you start thinking about it and where the water is going to flow. Is there an alternative? Do we have to use a silt fence? Do we have to use a fiber roll? Why can't we use soil? Why don't we just use and build instead of these silt fence in here, because that's where water is going to go to, and that might be happening. That's another one I saw earlier today. Why not just simply make sure as you go down and developing that you make sure there's always going to be an earthen berm that diverts the water the way you want to. We don't need to put all the fiber rolls in there. We don't need to put silt fences in there. Use the berms. That's just one idea. I know I'm crazy. I have this crazy attitude. But you think about where the water, this was berms, you got some water that's going to be diverted this way, within, and so forth, all the way over to there. This turned out to be about 30 acres, comes down to that point there. Noah's flood is on that one. All these points are where the water is going to go to. If the water is going to be concentrated here, 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 and here, why don't we put them into a pond? Why do we have to put a silt fence up? Just thought I'd ask that question. This is where it is. Here's the pond, here's the pond, here's the pond, and here's the pond. If you look at it, water can go in there. Make that part of your plan. That's your sediment control there. So those sediment controls are much more effective than all the fiber rolls and all the silt fences that you can put on a project, because you're going to collect water in the right spot. So questions for using sediment control: can you use diversion or erosion control techniques to help augment what needs to be done for sediment control? I'm not going to give you the one answer. If I went in here, there's probably 60 different answers people could come up with, and that's good. Can diverted waters be treated by a sed basin? This means that whoever's acquiring the right-of-ways, you're going to have to work with them. If they ignore you, okay, you do the best you can. I'd like to see how you can put a sed pond 1 millimeter just that side of your property line, or line of disturbance. Can cost be lowered by all of this? And the answer is yes, all of that. It's just thinking out of the box. Get away from the template mentality that is the only way to do it. Look at everything, because every one of you, you're a heck of a lot smarter people than I ever could be on this one. And you have one of the toughest jobs in the world, trying to build a highway. I don't know how you do it without disturbing the ground. Thank you so much.